This video will review graphing lines in point-slope form. This right here is an example of what point-slope form looks like. Y minus y1 equals m times x minus x1. Reminder that m is your slope, and that the reason it's called point-slope form is that there's also a point that can be easily found by using this equation, and that is x1 comma y1. That's our point. So when we do these problems, we are looking for a point and the slope from the equation. So, starting with our point. Our point comes, again, this is our x coordinate right here. Oop, let's undo that. So again, our point is x, y right here. So the first thing to remember is that when you put your point in here, you have to be careful that you find your x coordinate right here over here with this x right here variable. So over here is where our x1 is found, x sub 1. So because the way that the equation is written in general has a minus sign right here, and this is a plus sign, we actually would need a minus a negative 5 to make it a plus. So even though this looks like positive 5 here, what the x1 coordinate is negative 5. Negative. Same thing goes for our y1 value. So right here is our y1 value. And again, it looks like subtracting y1 here. So this subtraction sign tells us that what comes after it is our y1, which is 3. So our 3 goes here. The other thing we can read from this equation is our slope. And our slope, of course, comes from the number right outside the parentheses with the x coordinates. So this right here is 2 for our slope. Slope can be also written as a fraction, 2 over 1. So now we will plot the point, and then from the point we will use our slope. Plotting our point at negative 5, 3. So we're going to go negative 5 on our x-axis. There's negative 5 and positive 3 on our y-axis. So we need to plot the point. From the origin we go negative 5, positive 3, and that's where the point will be found, at negative 5, positive 3. Now from that point we're going to use our slope. Our slope is 2 over 1, which means rise 2 and run 1. So we're going to rise 2 units. We have to go up 2. Up 2 and right 1. So we're going to get that point right in here. A little bit hard on this graph here. And that is how we find our line. Again, because the slope of a line is the same anywhere on the line, so if we know one point that's on that line, we can start from there and then use the slope to draw it. Our second example, again, we're going to start by finding our point and our slope. Our point, the x-coordinate comes from over here. Again, it's positive 4, so that means the x-coordinate is negative 4. Over here, our y value, okay, comes from next to the y, positive 2, which means our y1 value is going to be negative 2. Our slope comes from right here in front of the parentheses with x minus x1, and that's negative 1/3. So we start by plotting the point negative 4, negative 2. So from the origin we move left 4 and down 2, and that's where we put our point. Again, not right here. That's not our point. That was just me showing you I'm moving over negative 4. And then after we use negative 4, negative 2 as our starting point, we know that that point is on the line, and then we know that the slope of that line, no matter where you are on the line, is negative 1/3, which means it's a rise of negative 1 and a run of positive 3. So rising 1, we'll go from here, right here, up 1, down 1. We're going to go rise down 1 because of this negative right here. So down 1 and right 3. So from here, we're going to go down 1, and then we'll move right 1, 2, 3. And our point's going to be right here. Again, using that little tick mark there to represent that. And now we can draw our line. And to think about it for a minute, we know our slope is -1/3, so it should be going downhill, which our slope is indeed, and that line going down.